Okay, so today's lesson is how to determine or how to make inverse functions. So what we have learned more than anything is that every x and every y have exactly one unique element paired to it. So for example, you've got a horizontal line test. So if I had a graph that looks like this, this will not have an inverse because it fails a horizontal line test, okay? It has to pass a vertical and a horizontal. Easiest way to make an inverse is you switch x and y values. So every x and y flip around to become a y and an x. This little symbol here means it's the inverse f negative 1. That means the symbol of inverse, okay? Do all functions have an inverse? No. Check this one out. It fails the horizontal line test. So let's take a look at the notes, right? So again, our topic today is how to make an inverse. Okay, how to make an inverse. So right off the bat, example 1. If I need to take a look at example 1, first of all, let's graph it, okay? X cubed. Well, I know what x cubed looks like, but if you're not sure, you can always put it in your calculator, right? Again, there's nothing wrong with the calculators. So if we go y equals clear, and I go x to the third power, and it looks like this. Well, let me get a better window. Okay, there it is. Okay, it looks like that. And if I did a t-table in my head because I'm smart, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, right? 1, 2, 3, 4, 5, up here at 8. 3 cubed is 27, but way too high for me. Negative 1 cubed is negative 1 times negative 1 times negative 1, which is a negative 1. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is a negative 8, which is way down here somewhere, right? So my graph looks like this. Alright, it is a function. It would pass a vertical line test. And it has an inverse because it would also pass a horizontal line test. So yeah, this one's 1 to 1. Yes. Yes. It's going to be 1 to 1, which means it has an inverse. And we'll figure out what its inverse is later. Okay, for right now, just yes or no, does it have an inverse? Okay, B, it's a parabola. It's going to start down at negative 4. 1, 2, 3, 4. And I'm going to do the parabola just in my head. We can put it in the calculator, but 1, 1, 2, 4, 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We did this the other day, right? 1, 1, of course it's symmetrical. And if you're not sure what I'm doing, you can always put it on the calculator. But basically what I'm doing is starting at the vertex, which is at negative 4, and squaring numbers. Over 1 up 1, over 2 up 4, over 3 up 9. Now, is this 1 to 1? No, right? This one's going to fail the horizontal line test. Boom, bad news, boom, bad news, bad news, bad news. So this one is not, this one's no. It is not 1 to 1, so it will not have an inverse, okay? It won't have an inverse. Okay, am I going too fast or am I okay? C, the square root graph looks like this. Square root of 0 is 0. Square root of 1 is 1. I'm going to jump all the way to 4 because I like 4 better than 3 and 2 because the square root of 4 is 2. The square root of 9 is 3. Okay, now I can't do negative square roots, can I? I can't do negative square roots, so my square root graph looks like this. Now, if you're not sure and you get to a quiz and you're like, gosh, Mr. Davies, I don't know what it looks like, you just put it on your calculator, right? Square root of x, and it looks like this, okay? It looks just like what I just put up there, huh? Except for that smudge on there, okay? So, will that pass a horizontal line test? Yeah, it will. It's going to pass horizontal line test, so yes. This one is 1 to 1. Every y has a unique x, and every x has a unique y. There's only one point, no double points, okay? So, in example 2, it says f of x equals x squared minus 4. That's this one here, right? It's not one-to-one. So if I really need it to be one-to-one, what I can do is change the domain. What I'm going to do is this. I'm going to erase the back half of this graph. Just going to get rid of it. But in math, you can't just do that, because math, there's always these rules, right? But if I do want to get rid of the back half of the graph, or the front, either one, but if I get rid of one or the other, usually it's the back because it's getting rid of the negative. If I get rid of this back half, the way I can do this is to change its domain and say, let's let x only be greater than or equal to 0. If I were to graph that graph, it would look like this. Where I'd only graph it from x being greater than or equal to 0, right? And the back half wouldn't be there. So what I can do sometimes is fix a function, change its domain so it will be one-to-one. Because if I get rid of the back half of this graph, this right here, this little statement here, got rid of the negative part of the graph. It says keep x positive. Don't even graph any negative ones, and you get this half, which this would be one-to-one, right? Turns out these two are inverses of each other. We'll talk about that here in a bit. Okay. All right, example 3. If f of x is equal to 3x plus 4, graph f of x and its inverse. Okay, well, graphing this is pretty easy. We know how to graph this. We're going to start at 4. 1, 2, 3, 4, right? I'm going to go up 3 over 1, up 3 over 1, but I'll go just the opposite, right? How am I doing? Here's my line. Here's my graph. Right? Start at positive 3, up 3 over 1, or down 3, back 1, down 3, back 1. How am I doing? Okay, Quinn? Doing good, right? So that's f of x. That's just plain old f of x. Now, what about its inverse? Let's do it. I'm going to do it the long way, if I can keep Quinn awake. I'm going to do it the long way. I'm going to do it point by point. Okay, check it out. So if we want to do the inverse, we're going to switch points. Remember? We're going to make our x, y's become y, x's. Okay, so point by point. So, first of all, this point right here is at negative 1, 1, right? You agree with that? Switch it. If I switch negative 1, 1, what does it become? 1, negative 1. That's right there, isn't it? Okay. This point right here is at negative 2, negative 2. Well, switch negative 2, negative 2. What do you get? You get negative 2, negative 2. You do. It's its own. It's its own inverse, right? Isn't that weird? You're going to see why in a bit, okay? How about this point? This is the point at 0, 4. What's the inverse of 0, 4?
4, 0.
Yeah. 1, 2, 3, 4, 0. It's right there. There's 4, 0. This point right here is at 1, 1, 2, 3, 4, 5, 6, 7. So 1, 7. Switch it. What's it become? 1, 2, 3, 4, 5, 6, 7, 1. It's about right there. Okay, there's 7, 1. And let's graph it. So the inverse is going to be this one right here. Okay, that's my inverse. That's f inverse of x. Okay. Now something kind of cool happened. I thought it was kind of cool, but I'm a math guy. Remember, I'm a math nerd. At negative 2, negative 2, they became the same point. So it's its own inverse. Okay. So what happens is this. If you switch x and y's, if they're the same x and y, it's your own inverse. That makes sense? 1, 1 would be 1, 1. Okay. So 1, 1 would be its own inverse. 2, 2. 3, 3, switch 3, 3, right? You switch 4, 4. 5, 5, 6, 6. 0, 0, right? So it turns out that on this line right here, Nikolai, you talked about flipping, right? A reflection. Turns out that every graph and its inverse are a flip or a reflection over this orange line. Can you see it? Can you see how this graph, if I were to take a barbecue skewer, right, a barbecue, and just rotate it, that this line would flip onto this line, wouldn't it? So the line of reflection for an inverse, so the line of reflection for a function and inverse happen to be the line y equals x. because that's what that line is. That's the line y equals x. So every time you flip over that line if it's a function that's inverse, okay? All right, now, it gets to be kind of a pain to have to go point by point by point. So, boys, what if we switched all of the x's and all of the y's? If we switched all of them, right? Either that's a whole lot of points to do, or x's, variables represent all of them. Y's represents all of them. Let's just switch the x and y's. So to make my inverse equation, okay, inverse equation, we're going to switch the x and the y variables. Okay. So to do an inverse equation, we're going to switch the x and y variables. So let's take a look. So f of x, it's just a fancy way. F of x is the same thing as y, right? So I have really y equals 3x plus 4. Okay, we talked about f of x and y being the same thing. Okay, so if I want to come up with this equation, and the inverse equation, all I'm going to do is take and switch. I'm going to rewrite it. So if I'm looking for the inverse, I'm going to rewrite as x equals a 3y plus 4. That's all I did. Easy. Now, it's not in a very nice form. Let's go ahead and fix it. So let's fix it by solving for y. So it looks like an equation, right? So if I solve for y, I'll bring over the 4, right? An x minus 4 equals 3y. Divide by 3, and x minus 4 over 3 equals y, okay? That's the inverse equation. Or, I'm going to write a little bit nicer, okay? Or another way to write this is f inverse of x, okay? That represents my inverse, is equal to, and I'll write this as a 1/3 x minus 4/3, okay? All right, let's check it out. Let's check out my inverse line, okay? So look at my inverse line, negative 4/3. That's right about there, you agree? Doesn't that look like about negative 4/3? Up 1 over 3, does that look like up 1 over 3, right? So sure enough, this is the equation of my inverse line, okay? All right, how am I doing? Don't fall asleep on me. Okay, turn the page. All right. Let's go back to this one. Example 4, okay? So again, what we're going to do now is fix functions to have inverses. Now I'm going to do this in pencil because I have to do some erasing, okay? So first of all, if I graph x squared minus 4, we just did this, right? I'm going to start at negative 4, right? I'm going to go 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing on the other side because it's a parabola, right? And they're symmetrical, okay? Now I'm doing it in pencil because I really am going to erase some of this graph, okay? All right? So there it is. X squared minus 4. It is a function. It's not 1-to-1, right? Not 1 to 1. But it is a function. Okay, so first of all, the domain. So the domain of this thing, think about it. Domain, a couple of ways to do domain. 2 ways. Listen, domain. You guys have a tough time with domain. What can x be? Or how wide is it? It's kind of the same question. What can x be? Well, I can plug anything I want in for x, can't I? And it is forever wide, even though it looks like it's going up forever. I mean, it's forever wide. It's always going to be going over. So the domain, in this case, is all real numbers. Okay, domain is x equals all real numbers. Okay. And the range, what about the range? What about the range? Reach for your range. What's the range going to be? Good. We're going to say y is greater than or equal to negative 4. Nice job, Colby. Totally agree with you. Totally. Right? All right, now let's figure out what the inverse is. So before I do a whole lot though, what I've got to do is graph the inverse. Now first of all, if I graph the inverse, I'm going to go ahead and put the inverse down. So I'm going to go point by point, okay? This is the point at 0, -4, so its inverse would be at -4, 0. 1, 2, 3, 4, 0, okay? You with me? That point right there is 0, -4, so its inverse would be -4, 0, okay? This point's at 1, -3, so its inverse would be at -3, 1. This point's at 2, 0, so its inverse is at 0, 2, right? Okay? This point is at -1, but I'm not going to do this one. I'm going to stop for a second. I'm going to go, wait a minute. First of all, you told me, Mr. Davies, this thing didn't have an inverse. So I got to fix this thing, okay? So what I need to do is fix this. Now, earlier, what we did was we said, wait a minute, we got rid of the back half of this, right? How did we get rid of the back half of this graph? We made a statement, right? Remember the statement we made to get rid of this one? What do we say? What do I want to write to get rid of this back half of this graph? I said x is greater than or equal to 0, didn't I? So I got only this. So let's do that right off the bat. So before I go any further, I'm going to say, wait a minute. Let's fix this. Let's make sure x is greater than or equal to 0. And then I'm going to erase the back half of this graph. Okay. Now, if I had left it, and I'll do it on the whiteboard because it's wrong. It's very wrong. If I left it, check it out. I would have had this. I would have had black. There we go. Okay, so check it out. So here's what it did look like, all right? And here would have been the inverse. What's wrong with the inverse? Not a function, is it? Do you get why it has to be 1-to-1? If it's not 1-to-1, then your inverse won't be a function. We can't graph things that are functions, right? So if it's not 1-to-1, it won't have an inverse unless we fix it. So what I did to fix it, I said, all right, let's get rid of this back half here, right? And when I flip it, when I get rid of the back half, it gets rid of the negative half of this one, right? And then, lo and behold, you have a function that's 1-to-1, and you have an inverse, okay? Awesome. So, what we have now is a function and its inverse. Well, let's keep going with this, all right? So now, what's the domain of f inverse of x? Now that we've got it there, what's the domain of f inverse of x? Domain. What's the domain of this? It's x is greater than or equal to -4. And what's the range? Greater than or equal to 0. Okay, so we get y is greater than or equal to 0. Okay. Now, if I go back to this domain, we fixed it, right? This domain is no longer x is equal to all real numbers because we made a change. We said really x is greater than or equal to 0, didn't we? So that we only have the front half. So, do you notice anything between these two? I'm hoping you will. Hoping somebody's going to tell me something very bright and intelligent. What do you guys see? Anything? So the domain of this one is the range. So the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. Well, that makes total sense to me because the x becomes the y and the y becomes the x. The x is the domains and the range is the y. So the domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse because x and y switch. Totally makes sense. Okay, for time, I will leave this one off, and I will even change some of the homework. All right, so I hit record.